In order to understand how a net force causes a change in motion, it is important to understand how physicists use motion plots and equations to calculate acceleration. You are probably already familiar with the term acceleration. You've seen TV commercials advertising a sports car that is able to go from 0 to 60 in only 3.7 seconds. The commercial is bragging about the car's acceleration, or how quickly the car changes its velocity. Every year, car companies try to increase their sports car's acceleration, which of course means lowering the time needed for a car to reach the typical highway speed. Acceleration is the time rate of change in velocity, or how quickly velocity is changing. Let's look at the velocity versus time data for 4 cars and rank their acceleration from smallest to largest. Since acceleration is the time rate of change in velocity, the lowest acceleration is car C, since its velocity doesn't change at all. It has an acceleration of 0 meters per second squared. Before we talk about the next greatest acceleration, you should know, in physics, negative accelerations are not less than positive accelerations. So the next greatest acceleration is car D, whose acceleration is negative 1 meters per second squared. Car D's velocity decreases by 1 meters per second each second. The third greatest acceleration is car A, whose acceleration is positive 2 meters per second squared. Notice that the velocity of car A increases by 2 meters per second each second. The car with the greatest acceleration is car B, whose velocity increases 3 meters per second. Its acceleration is positive 3 meters per second squared. There are 2 ways to have zero acceleration: remain at rest or move with constant velocity. An object's velocity is constant when its speed and direction don't change. Acceleration is equal to the change in velocity divided by the change in time. In this problem, the velocity changes by 20 meters per second. That's positive 20 meters per second west, and it does it in 5 seconds. The acceleration is 4 meters per second west. We always include direction when we calculate the acceleration if it's given in the problem. Let's take a closer look at the units in this answer. Physicists don't actually use meters per second. Instead, they multiply the numerator and denominator by seconds. The units now become meters per second squared. In this example, the change in velocity is negative 15 meters per second west because it goes from 20 down to 5. This change occurs in 5 seconds. The acceleration is negative 3 meters per second squared west because negative 15 divided by 5 is negative 3. You can say negative 3 meters per second squared west, or you could say 3 meters per second squared east. The negative makes the west east. A deceleration is sometimes called a backwards acceleration. Decelerations are caused by forces that are in the opposite direction of the motion. Let's summarize. Displacement is distance and direction from start to finish. Positive and negative can be used to designate a direction. Negative values are not smaller than positive values in physics. Acceleration is the time rate of changing velocity. Velocity is speed in a particular direction. There are 2 ways to have zero acceleration. You can remain at rest or maintain the same speed and direction. This is the end of my presentation on acceleration.